Hello, everybody. For this next set of videos, we're going to be looking at all 100 questions of your semester one exam review. So we've broken this up into much more manageable chunks here. Part one will deal with just questions 1 through 20. Let's go ahead and dive right in here. For question one, you're given the following situation. If you opened up a laptop and positioned the screen so that it was a right angle, 90 degrees, let's say you could push it further beyond 90 so that it ends up flat, and you're asked, what's the angle called? What's the measurement? So we're talking about basically what is the degree measurement and what is the name of an angle that lays out as a straight line. It has to be 180 degrees, and clearly, since it is a straight line, it's also going to be a straight angle. So we have a straight angle that's 180 degrees and one down with 99 to go. For question two here, we are given a definition, a portion of a line that's bound between 2 points. So if we draw 2 endpoints here and take only this part of a line, we're basically asked, what is this? And if we look across all the words here, the only one that matches, it must be a segment. Well, that is the definition of segment, bound between 2 endpoints. For 3, we're going to match up some details here. So for first one, for A, we're given linear pair. So we are looking for 2 angles that would be side by side forming a straight line. Only pictures 3 and 4 potentially show this. Now it's just a matter of what do the angles actually say in these two. So in 3, we have angle AEB, which would be the one on top here. And we also have angle CED, which would be the one across from it. That's not a linear pair, so odds are 4 is the correct answer, but let's be thorough. AEB is the one on top again, and AEC is the one next to it. These two, so this one is where our A is going to go. It must be picture 4, but that does help us with the next one as well. We're asked to put the vertical angles, and that's the one we just saw in picture 3. Let's see, for the next one, angle bisector. We're looking for angles that are split in half here. If you start looking across the pictures, we can throw out 2. That's clearly not angles in that picture. 1, 5, and 6, the only one that looks like it is split up in some way is you're taking a look at picture 6. You have angle ABC, the top portion, and angle CBD, the bottom portion. So here is your bisecting of an angle. D is parallel lines. Well, there's only one picture left out of the pile that looks parallel, so clearly it has to be 2. And then E and F are your triangle centers. One's the orthocenter, one's the centroid. You can define either one, but we'll just take them in order here. Orthocenter is built out of the altitudes, so it has to be all the ones that are a right angle, like this picture. So this has to be the orthocenter that's been created where these 3 lines cross, which by process of elimination means this has to be the centroid here in picture 1, which we did know because we have a line coming off a vertex and it's passed through the midpoint. So you know you're creating the midpoint in all of them. That's the idea. Next up, whoop, too far. For number 4, we'll take care of the last of the definition questions by looking at what terms can actually be defined. So we have to go all the way back to the very beginning of the course here. There were 3 terms that are listed as the undefined terms. Point, line, and plane are undefined. The most we can do is give a description, but everything else is built out of these 3. So we need to throw point, line, and plane off the list, at which point the other 4 are all things that can be defined. Space is the entire region where all the points lie. Parallel is 2 lines running in the same direction that don't cross. Segment we defined earlier in number 2. Ray would be the portion of a segment with an end point and then going in one direction forever. All the rest of them have a definition. All you can do for point, line, and plane is give a simple description. Let's see, for number 5 here, you're given a couple of reflections to deal with. So if we reflected this point across x equals -3, so let's start counting. From here to here, there are 4 for the distance, 4 boxes. So we're going to go the same in the other side. If we go 4 units on the other side, we end up here. You can count them. And then we have to also reflect it across y equals x, which means it's going to just simply change its signs and flip over to the other side over to here. At which point, which may not change its signs, change its order. So at which point we're just looking for which numbers actually do that. You can count them off, or you could actually do the formulas with the numbers to start with. Either way, you're going to end up with this point being 4, 1 to make the correct answer D. All right, for number 6 here, same idea. We're given another transformation, but this time without the graphs. You're going to have to actually use the formula work. You're given 4, -8, 4, 8, and you're asked to flip it over the x-axis, which if we do a quick sketch, you're going to flip it from top to bottom, which is why I said negative earlier. All that's going to do is alter the sign of the y value. You're going from top to bottom, so 4, -8, which in turn to make the answer C. For the next page here, we'll start with number 7. You're asked to find the distance between these two cities, rounded off to the nearest tenth. So we'll find the distance formula or the Pythagorean theorem. Both ideas are the same idea. We need to find the distance between the x's. So we're going to go to here, and then we're going to go up to here. So from 0 to 5 is literally a distance of 5. And then from 0 up to 6, a distance of 6. Again, distance formula, Pythagorean theorem, they're the same concept. So we're going to take the square root of 5 squared plus 6 squared, to become the square root of 25 plus 36, to become the square root of 61. Now, clearly 61 is not a perfect square, so we are going to end up with a decimal of some kind. We get 7.8102 and so on. You were asked to round it off to the nearest tenth, so 1 decimal place. We will say that these two cities are 7.8 units away from each other. For number 8, we're asked another transformation question, so we basically need to go see what happened to these points here. We're asked to select all the transformations that could have turned our original square ABCD into our A prime, B prime, C prime, D prime square. So we just start checking them. And the easiest way is to actually literally look at the list here. If we draw the line y equals x, that would be this line here. If I reflected the square across it, there's no way it moves to there. So A is out. The line y equals -2x. Now, if we try to draw that one, so -2x is going to be sloped through here. Same thing. If I try to reflect it across it, you're too steep. Maybe if it was -x and it just went directly diagonal, that'd be a lot better, but there's no way that one's going to work. It just doesn't fly. The -2 messes that up because it's slanted, so it has to end up slightly off. It can't be perfectly diagonal because of it. A rotation of 180 degrees. So if we went from here, 180 degrees around the origin, well, sure enough, that one does work. So C will keep. A reflection across X and then across Y. If you remember from the transformations chapter, that is the same thing as a rotation of 180. So it has to work without even trying to draw anything. And it's the same thing as C. C and D are the same statement. And then a rotation of 270 degrees counterclockwise. So if we go 270 counterclockwise, we end up here. And then we're going to flip it across the x-axis, which is going to put it right back where it started. E's out. E turns it back into itself, not into the one on the other side. So only C and D will work for that one. Let's see, on to number 9, another transformation here. You're asked which one of these transformations turns the trapezoid into itself. So again, it's basically test them. Let's go through and see which ones actually do something. So if we go counterclockwise rotation 90 degrees, well, if we go 90 degrees counterclockwise, our trapezoid looks like that now, so that's a no. If we rotate 180, it's now just upside down. so that's still a no. It doesn't turn it back into itself. If we reflect across x, I get the same picture again. But if I reflect across y, this point goes to here, while this point goes to here. This one goes to here, while this one goes to here. D will end up working out. 10 asks the same kind of question. Which transformation is going to turn the rectangle into itself? So same idea. We're just going to go test them all and see what would happen. If we started with a reflection over line M, so then this point would come here and then reflect over to the other side. That's clearly a no. Reflection over y equals 1. So if I draw a line here for y equals 1 and flipped it, this point would come to here, and this one would go up. This one would come to here, and this one would go up, at which point we're good to go. We don't even have to check the other two. But you can real quick. I mean, 90 and 270 degrees, you know both of those are going to turn the rectangle, instead of being long left to right, they're going to eventually leave it long top to bottom. So, it's not going to be exact. Let's see, for 11, we'll get into a little bit of symmetry here. For this plus sign looking figure, we're asked to find all the lines of symmetry in it. So just start thinking about how you could fold it in half. You could fold it in half from top to bottom, and you could easily fold it in half from left to right, which now if you start looking at the answers, C gets thrown out. This line does not fold it in half perfectly. If you wanted a diagonal line, it would have to go that way. So now if the other two you start looking at, clearly B's got this top to bottom and left to right, and so does A, but A has the extra, what if I folded it across a diagonal, and what if I folded across a diagonal? A ends up being the correct answer. See, similar to the last question, now let's do a little bit of error analysis. One student looks at this picture and says there are 10 lines of symmetry, so what mistake have they actually made here? Think about what you have. You have a pentagon, so there's 1, 2, 3, 4, 5 lines of symmetry, not 10, which if you start looking at the answers, counted the total number of arrowheads when it should have been just the number of lines. That's the error that's been made. You have a pentagon, a regular pentagon has 5 lines of symmetry, 1 through each side and the angle across from it, as the picture showed. All right. For 13, more transformation work. So here is a figure and its transformation, and we're asked to figure out what was actually done to it. The easiest way to do these is literally highlight one point and see what was done to it. So in the first picture here, we'll take point H, for example. Point H moved 1 step down and 2 steps to the left to become point H prime. Moving directions is the definition of translation. Now we'll take a look at the second picture here. K moved over to here, but then if you look at P, that'll be the other one. It moved the other way over to here, P prime. That's the idea that you're getting points that are flipping locations, and flipping has to be reflection. Also, you could always just draw the line down the middle. Clearly it flipped over this vertical line down the middle. Speaking of more transformations, here's 14. If we took the point 11, -4, and then use the translation of -17 to the x's and +2 to the y's, what would be the new image point? Well, 11 minus 17 is -6, and -4 plus 2 is -2. So we are looking for -6, -2, which is clearly A. For 15, same idea, but this time not multiple choice. Point Q was at -2, 3, and according to the table, Q prime was at 4, 7. You're asked to fill in what are the values of A and B to make this transformation true. So basically, what happened? To get from -2 to 4 must have been adding 6 to the x values. So x plus A must have actually been x plus 6. And to get from 3 to 7 is adding 4 to the y value, so y plus b must have been y plus 4. And then for 16, you're given the following: two transformations if we compose them together, but what would it become as a single one? Easiest way to do that is actually just physically combine them. We're going in the first one, 4 units up and 4 units right. So for the x's, that's going plus 4 since we're going to the right. And for the y's, that's also going plus 4 since we're going up. Then we're going to go 3 left and 7 up. 3 left would be subtracting 3, and 7 up would be adding 7. So very literally, combine these together. Positive 4 and negative 3 means as an overall, we've added 1 to x. And then positive 4, positive 7 means as an overall, we've added 11 to y. So we are looking for the single transformation that does x plus 1 and y plus 11 for the correct answer to be D down at the bottom. All right, for 17, you're given the triangle's vertices as well as what their image was after one of these 4 transformations was done. So now it basically becomes what has happened here. So we take a look at, we have -3, -1, and it was changed into +3, -1. We also have -6, -5 for B, and it was changed into 6, -5. And then for C, we have -1, -4, and it was changed into +1, -4. So the only alteration that's happened in all 3 points is the sign of the x coordinate has changed. They were all negative, they all became positive. If you consider a graph, the only way you change x coordinates is to go from left to right or from right to left, which means we flipped it over the y-axis. Look down the list, correct answer ends up being B. We reflected it across the y-axis and changed the signs of the x numbers. For 18, we're given the same 2 pictures, just like we were in a previous question, and asked which of these transformations would actually create this. Easiest way to do which of multiple choice questions is to test them. So we'll just start with A and check them. If we took a reflection over the x-axis and then a reflection over the y-axis. So we'll take point A here, for example. If we go across x, it ends up here. And then if we go across y, it ends up over here for point D, at which point we're good to go. You're asked which of these would turn A, B, C into D, E, F. Well, there's the one that turns A into D. You can check the rest of them, but it'll work just as well. B will come up here and then flip over to E. C will come up here and then flip over to F. So it works out perfectly. Lucky for us was the first one. We don't have to check too many things. All right, for 19 here, we're asked to come up with what's the actual image after we apply this translation, add 1 to x and subtract 4 from y. We'll very literally just count the points and then list them off, make it really easy. So V, T, R, and S are located at, see, V is -4 and +3. So if we change it, we add 1, that'll be -3. We subtract 4, that'll be -1. So we'll be at -3, -1, which now if you start counting, if you count off the graph, we literally went +1 and -4 to create that point. We don't got to draw it for every single one of them, but it illustrates the idea really quickly. T is at -1, and then 1, 2, 3, 4, 5, 6. So if we if we add 1, we'll be at 0. If we subtract 4, we'll be at 2. R is located at 3, 3. So R prime, if we add 1, we're at 4. If we subtract 4, we're down to -1. S is centered at the origin. So if we take it and add 1, we're at 1. We subtract 4, we're at -4. If you graph these 4 points, they will be the entire picture moved 1 step to the right and 4 steps down. Last but not least for part 1 here, we're given another transformation. A quadrilateral was rotated around some point, and you're asked to select all of the statements that would be true about it. The key to this question is remembering one simple rule. Transformations, rotation, reflection, translation, they are basically the building blocks of what make congruent figures. So you're looking for basically what is true about the congruency figure here. So JKLM and JKLM primes. All we gotta do is just test which ones are actually true. So LM being congruent to JK, well, I'm pretty sure the second one here, this does not say JK, so we'll get rid of that one. KLM for that angle to be KLM and prime. I agree with B. And notice this is exactly what we're doing. We're just matching up the letters. Do they match up to what they have? So I don't even have to write the rest of it on the right-hand side here. The segment J prime and K prime should match the segment JK, absolutely. The angle JKL prime should match up to the angle JKL, absolutely. K and L prime should match up to M and L. No, it shouldn't. Those don't match up, leaving B, C, and D to be the only answers on the list. That's everything for part 1 here. If you've got any questions, make sure to ask your teacher, and see everybody when we go jump into the next 20.